Hi, welcome to another edition of Bardon Technique TV, Tricky Math. Today,
Hey there.
we will discuss about
Subscribe to my
real
channel.
numbers,
And also press this bell icon.
natural or counting numbers. These are the set of numbers we use in counting. Example, ZP is equal to 1, 2, 3, 4, and 5 until the n number. So for the whole numbers, if we include the number 0 in set P, then we have a set of whole numbers. So set W is equal to 0, 1, 2, 3, 4, 5 until the n. Negative integer. These are the opposite of positive numbers. Example is the opposite number of set P. Set n is equal to negative 1, negative 2, negative 3, negative 4, negative 5 until negative n. So fraction simply tell us how many parts of a whole we have. You can recognize a fraction by a slash that is written between two numbers. We have the top numbers, the numerator, and the bottom numbers, the denominator. So examples of fraction, 1 over 8, 3 over 5, 4 over 6, 3 over 8. So at 1 over 8, we have 1 is the numerator and 8 is the denominator. At 3 over 5, we have 3 is the numerator and 5 is the denominator. When any two integers form a ratio such that 0 is not a divisor, they become a fraction. The set of all fractions is the set of rational numbers. Any integer is also a rational number since it can be written as a ratio between itself and 1. Examples: rational number between 0 and 1 is 1 over 2 or 1 half, 1 third, 1 over 4 or 1 fourth, 1 over 5, 1 over 6, 1 over 7, 1 over 8, and so on. So example number 2, rational numbers between two fractions 1 over 2 and 1 third, 7 over 20, 11 over 20, 30, 23 over 60, 2 over 5, 5 over 12, 13 over 30, and so on. All fractions can be changed to decimals. They can be either terminating or repeating. So examples of terminating. 7 over 20 is equal to 0.35. So if we change the 7 over 20 into decimal, it will become 0.35. So it is terminating. The same with 1 over 4 is equal to 0.25. And 1 over 2 is equal to 0.5. We do this by dividing the numerator over the denominator. And then for repeating, the same, 11 over 30, 11 divided by 30 is equal to 0.36666. And 1 over 3, 1 divided by 3 is equal to 0.333333. So irrational numbers, not all decimals can be changed to fractions. Example, 0.1234567 is neither terminating or repeating. They belong to irrational numbers or irrationals. So therefore, for the real numbers, when the set of rational and irrationals are put together, we form the real numbers. Real number system. Set of real number together with the operations, addition, and multiplication form the real number system. The properties of real number system. Number 1 is the closure property. For any real numbers a and b, the sum of a plus b and the product of ab are also real numbers. Example, for sum a plus b is equal to real number, we have 3 plus 7 is equal to 10, where a is equal to 3 and b is equal to 7 and 10 is the real numbers. 3 plus negative 5 is equal to negative 2, where a is equal to 3 and b is equal to negative 5 and the negative 2 is the real number. For product AB is equal to real numbers, we have 2 multiplied by 4 is equal to 8. A is equal to 2, B is equal to 4, and 8 is the real number. Negative 0.4 multiplied by negative 12 is equal to positive 4.8, where A is equal to negative 0.4 and B is equal to negative 12 and 4.8 is the real number. 3 multiplied by negative 2 is equal to negative 6, where A is equal to 3 and B is equal to negative 2 and the real numbers is negative 6. So that's all for that. The second real number system property, the commutative property. For any real numbers a and b, for addition, a plus b is equal to b plus a. And for multiplication, it may appear like this and this. A asterisk b is equal to b asterisk a is the same as open and close parenthesis a to open and close parenthesis b is equal to open and close parenthesis b to open and close parenthesis a, or a dotted b is equal to b dotted a. All of this may appear as multiplication. Example number 1. For a plus b is equal to b plus a, we have 3 plus 9 is equal to 9 plus 3, where a is equal to 3 and b is equal to 9. And the answer is 12, which is equal to 12, which proves that a plus b is equal to b plus a. Example number 2. For AB is equal to BA, we had 7 multiplied by negative 4 is equal to negative 4 multiplied by 7, where A is equal to 7 and B is equal to negative 4. The answer is 7 multiplied by negative 4 is negative 28, and negative 4 multiplied by 7 is equal to negative 28. So, the same. For example number 3, for A plus B is equal to B plus A again, we have 3 plus 8 is equal to 8 plus 3, where A is equal to 3 and B is equal to 8. 3 plus 8 is equal to 11, and 8 plus 3 is equal to 11 also. For example number 4, for AB is equal to BA again, we had 12 multiplied by negative 6 is equal to negative 6 multiplied by 12, where A is equal to 12 and B is equal to negative 6. The answers, 12 multiplied by negative 6 is equal to negative 72, and negative 6 multiplied by 12 is equal to negative 72. So that's it for commutative property. The third real number property, the associative property. For any real numbers a, b, and c, we had for addition, open and close parenthesis, a plus b plus c is equal to a plus open and close parenthesis, b plus c. And for multiplication, it may appear like this. A multiplied by open and close parenthesis b asterisk c is equal to open and close parenthesis a asterisk b multiplied by c, or also equal to a multiplied by b dotted with c open and close parenthesis is equal to open and close parenthesis a dotted with b multiplied by c. So example, 3 plus negative 9 open and close parenthesis plus 7 is equal to 3 plus open and close parenthesis negative 9 plus 7, where a is equal to 3, b is equal to negative 9, and c is equal to 7. So open and close parenthesis 3 plus negative 9 is negative 6 plus 7, and negative 9 plus 7 open and close parenthesis is equal to negative 2. So therefore we have 3 minus 2. Then the answer is 1 is equal to 1. For example number 2, we had 3 multiplied by 9 dotted with 2 open and close parenthesis is equal to 3 dotted with 9 multiplied by 2, where a is equal to 3, b is equal to 9, and c is equal to 2. So open and close parenthesis 9 dotted with 2 is also equal to open and close parenthesis 9 multiplied by 2, which is equal to 18, and 3 dotted with 9 is equal to 3 multiplied by 9, which is equal to 27 multiplied by 2. So therefore 3 multiplied by 18 is 54, and 27 multiplied by 2 is the same, 54. For example number 3, we have 4 plus 5 plus 7 is equal to 4 plus 5 open and close parenthesis plus 7, where a is equal to 4, b is equal to 5, and c is equal to 7. So 4 plus open and close parenthesis 5 plus 7 is 12, and 4 plus 5 open and close parenthesis is 9, then plus 7, we have 16 is equal to 16. For example number 4, we have negative 4 multiplied by 3 open and close parenthesis 6 is equal to negative 4 multiplied by 3 open and close parenthesis times 6, where a is equal to negative 4, b is equal to 3, and c is equal to 6. So therefore negative 4 multiplied by 3 times 6 is equal to 18, is equal to negative 4 times 3 is equal to negative 12 multiplied by 6. Therefore, the answer is negative 72 is equal to negative 72. So that is for the associative property.